Are you a student struggling to keep up with your lessons? Or a parent searching for a reliable educational resource that truly cares? You've come to the right place. Welcome to FEUNIX Distinctions, your premier channel for educational content designed for every learner. We understand the silent struggles that often go unnoticed, the frustration of slow-paced learners, and the need for solid foundations for all students. At FEUNIX Distinctions, we don't just teach. We are dedicated to guiding you every step of the way. Our teaching style is unique, simple, and incredibly effective. We make complex concepts easy to grasp and ensure that every lesson is both suitable and enjoyable, no matter your learning pace. Whether you're a fast learner looking for a new challenge or an average learner aiming to excel, our comprehensive methodology is built to support you. Join a community where no one is left behind. Subscribe to FEUNIX Distinctions today and hit the notification bell so you never miss a lesson. Let's make learning an exciting journey together.
So good day, viewers. You are welcome to this class, Lesson 2 Mathematics. We're moving on to Lesson 8. Our topic remains psychogeometry. We have solved some questions on psychogeometry in our Lesson 7. But in Lesson 7, we do more of solving exercises so that you can perfect your skills on Theorem 11. In Theorem 11, we look at angles at the center is twice angle at the circumference. Now we are going to move on without waste of time to Theorem 12. But we wish to do Theorem 12 and Theorem 13 today. Let's do our best to save time. Theorem 12. Theorem 12 states that angles in the same segment, same segment of a cycle are equal. Yes. Angles in the same segment of a cycle are equal. I will explain what it means by the same segment of a cycle. We are going to draw a cycle. We have a cycle here. All right. First of all, let me talk about a segment. Before we talk about, then we talk about the same segment. If we have a cycle and then we have a line here. Here, let's say I divide this line. I divide this cycle into two parts. We have one part here, we have another one here. This portion of it, this portion of the cycle is a segment. This other portion is also a segment. This line is called a chord. If you remember when we started this topic. This chord divided this segment into two. This segment is smaller than this one. So the smaller one is called the minor segment. The bigger one is the major segment. So anything that I will be doing here, I'll be doing it within the major segment. Anything I'll be doing here, I'm doing it within the minor segment. Please, I'm just doing this so that we'll understand what a segment means. So now we are going to go into our work proper. Angles in the same segment are equal. Let me put on an example here so that we can see. Let me draw some angles. Let's say we have an angle here. And we have another one here. This point, we call this point A, we call this point B. And likewise, this point can be called point P, and here is our point Q. This angle, let me call it angle X1. We call this one angle X2. Now this is it. X1 and X2, they are angles in the same segments. Angles in the same segments. That's the major segment. Remember, if I could draw a line here, this part is the minor segment, then the other part is the major segment. Now this is what you check basically if you want to get this. This angle X1 and angle X2, they have the same takeoff points and the same landing point. Angle X1 took off from this point A, touch the circumference, and return back to point B here. Likewise, angle X2 took off from that same point A, took off from point A, touch the circumference at this point Q, and then return back to point B. So you see, X1 and X2, they have the same takeoff and landing points. And also, they have the same direction. X1 is facing down, X2 is facing down. They are both facing down. They have the same takeoff point and the same landing point. They both touch the circumference. The same takeoff point, the same landing point, they touch the circumference. So they are angles in the same segments. So angles in the same segment are equal. X1 is equals to X2. We put value, supposing we put value for X1, let's say for example, if we put 14 here, and we are asked what is X2, X2 definitely will be 14 too. That is theorem 12. Theorem 13. It says the angle in a semicircle, angle in a semicircle is a right angle. Angle in a semicircle is a right angle. Angle in a semicircle is a right angle. This is a cycle. Let's draw a semicircle. You can draw it in any way. I decided to draw my semicircle this way. Yes. A straight line across the center of a cycle. This is the center of a cycle. I call it center O. This is a straight line that crosses the center of a cycle. The theorem says the angle in a semicircle is a right angle. That is to say, if we use this semicircle to form a triangle, that triangle is a right angle. A right angle is an angle at 90 degrees. So let's use this semicircle to form a triangle. We're forming a triangle now. We have formed a triangle. This part of the triangle is 90 degrees. from the theorem. The angle in a semicircle is a right angle. So if you draw a semicircle and then you use it to form a triangle, wherever it touches the circle, that place it touches it is 90 degrees. That's what this theorem is talking about. Let's solve just one example, and that is all. Example 1. In the figure below, in the figure below, PQ, that is line PQ, is a diameter. The diameter of a cycle. PMQN. PMQN. Center O. If PQM with the angle at Q is 63 degrees, find QNM. QNM. Let's solve this question. Here's our cycle. We're drawing the parts of the cycle in line with the question. We have N here. We have our P. This is center O. This angle is angle. This is M. And then this is Q. This point. Then this angle is angle 63 degrees. Yes. So let's check the question and then complete it. Find QNM. Find QNM. That is, this is the angle we are to find here. Now this is how we are going to approach this question. We are going to use theorem 12 and 13. That is why we decided to merge these theorems together. I can be able to get this angle using theorem 13, which says the angle in a semicircle is a right angle. This is a semicircle. This line that you are seeing here is a straight line passing through the center. Once you see something like this is the center of a cycle with center O. So once you have a line like this is a semicircle. Once you have a semicircle, the angle it forms when it touches the circumference is 90 degrees. That is to say, this angle is angle 90 degrees. So now that I know this angle, I also know this angle as 90. I can get this very angle using sum of angles in a triangle is 180 degrees. Sum of angles in a triangle is 180 degrees. This angle is 90 degrees. This angle is 63 degrees. And then I want to find this angle. Let me use X there to help me to get this angle. Once I get this angle, I'll be able to get this one using theorem 12. Because this angle and this angle, they are angles in the same segment. They have the same takeoff point. This angle took off from here, touches here, and then move down to this point here. This angle too took off from the same point, move up here, touch the circumference, and then it moves down to. So they have the same takeoff and landing point, and they are facing the same direction. This one is facing down. This one is also facing down. So they fulfill theorem 12. Angles in the same segment are equal. But we say before we get this angle, we have to use sum of angles in a triangle to get it. Let's use that. That will be 63 plus 90. 63 plus 90 plus x equals to 180. Equals to 180. So 63 plus 90 will give us 153. 153 plus x equals to 180. We will collect like terms. That is to say, this 153 will move over to the other side to go and meet its like term. So therefore, x equals to 180 minus 153. X will give us 27 degrees. We have found the value of x. We have found this angle to be 27 degrees. What will now be the value of this angle? It will also be 27 degrees because angles in the same segments are equal. So angle QNM, that's the angle that this question asks us to find. Angle QNM is equals to 27 degrees because angles in the same segment are equal. So that is it for now. I'm going to leave you with work. I want you to solve some questions for me as your assignment. Find the lettered angles. Find the lettered angles. Find the lettered angles. Question number 1. Find the lettered angles. There's a straight line here. with a point O as a semicircle. A line here and another one here. Another line here. And then a line here. I have an arrow here. Another arrow here. This is center O. This angle is angle F. This angle is angle 56. This is angle H. This is angle G. Please do this work. And if your work is correct, expect you to get angle F as 90 degrees, angle G as 34 degrees, angle H 56 degrees. Let me give you another question. We have a cycle here. Straight line. Straight line is here. Straight line is here. I have another one here. I have a straight line here. Now let me put the angles. This angle is angle Z. All of this angle from here to here, angle Z. This angle is angle Y. This place is center O. This is center O. And the angle is angle W. This is angle W. Here we have angle X. And this is angle 126. So you do this work. You are through. Compare your answers with these very answers. Angle W, you get 252 degrees. Your work is correct. For angle X, if you get 108, the work is correct. Angle Y, 54 degrees. Angle Z 126 degrees. Please compare your work with these answers. So thank you. Do your best to click the subscription button. Click the subscription button so that I will keep you posted whenever there is a new video. Thank you.